Howdy, my name is Noah Cusimano. I'm a software engineer at Livefront, and this is the State of Compose, an overview of Jetpack Compose. Jetpack Compose is a modern declarative UI toolkit for Android that fully integrates with Kotlin and simplifies UI development by allowing engineers to describe what their interfaces should look like based on the application's state rather than detailing the process of constructing UI step by step. We'll first review a timeline to gain the historical context needed to judge the state of Compose. My hope is that as you see the steps Compose has taken to reach the stability and capability it has achieved today, you'll consider taking the leap into Compose yourself. In May of 2019, Google announced Compose as an experimental tool for Android UI development, close on the heels of Apple's introduction of Swift UI. 2020 saw the release of the developer preview, alpha, and beta builds, which marked a more stable set of APIs, but still not recommended for production use. Version 1.0 was released July of 2021, making this a major milestone as it marked the general availability of Jetpack Compose stable for production use. Many significant improvements were made over the next few years, continuing to increase the reward and reduce the risk of transitioning. These improvements included lazy grid APIs, accessibility features, improved focus handling, animation updates, and major recomposition and startup time optimizations. As for the future roadmap, I'm very excited. Compose will only continue to become more optimal and integrated, even beyond the Android ecosystem, with the adoption of Kotlin and Compose multi-platform, bringing Compose to iOS, desktop, and web. With that context, let's now briefly look through some examples of Compose in action. If you're entering into a greenfield project, you will quickly discover the simplicity of getting started with Compose. After implementing the Compose BOM and setting minimal build features in Gradle, you are immediately ready to begin writing declarative, reusable composables in your app. One of the strongest reasons to consider Compose adoption is its convenient bidirectional interoperability. If there is ever a need to bring XML into our Compose UI, we were able to make use of an Android view to seamlessly carry that layout over into our composable. Similarly, if you find yourself with a brownfield project that you would like to slowly introduce Compose to, you're able to simply add a Compose view to your XML, find that view by its ID, and then can immediately begin calling composables. Now that we've seen the simplicity of Compose in action, let's explore the advantages that it has over its legacy predecessor, XML, which has encouraged many teams to make the leap. First off, Compose uses a declarative approach for UI development. This means you define what your UI should look like, not how to create it step by step. This can lead to more intuitive and concise code compared to the imperative style used with XML. It is built on top of Kotlin and leverages Kotlin's language features like type safety, null safety, and extension functions, making the code more concise and less prone to errors. It reduces the amount of boilerplate code you need to write as well. For example, you don't need to use find view by ID, and there is no need for XML files, which streamlines the codebase and reduces the chance of bugs. Next, Compose unifies everything into a single cohesive API, unlike the traditional approach which often requires updating UI elements in both XML and Java Kotlin code. This makes the development process smoother and faster, as everything from the layout to the behavior is defined in one place. It also simplifies state management in UI components. The framework ensures that the components are automatically updated when data changes, which helps manage app state more effectively and reduces the chance of UI inconsistencies. And of course, Compose can lead to better app performance, as it is capable of recomposing only the parts of the UI that have changed and need to be redrawn instead of the whole tree. This selective rendering can significantly improve performance, especially in complex UIs. And arguably, one of Compose's greatest strengths when it comes to adoption, as we saw in the previous examples, is bidirectional interoperability. Whether you have a legacy XML project that you would like to introduce Compose to, or you have begun a greenfield project in Compose and would like to carry over an important legacy view that you rely on, you are able to seamlessly work with both to fit your needs. Though Compose has seen great success and become an extremely versatile tool for many Android engineers, there are reasons that you might not find Compose to be the best fit depending on your team and project timeline. So we'll wrap up by taking a look at some of the considerations to be made when deciding whether or not Compose is a worthy investment, and weigh these considerations against the advantages and potential that we've seen. Though starting a fresh Compose project or integrating Compose into an existing project immediately allows you to jump into writing composables, engineers long accustomed to traditional XML and/or Java-based development may find the declarative nature of Compose and its Kotlin-centric approach challenging, requiring time to learn and adapt. Also, while rapidly improving Compose's ecosystem and community resources, including comprehensive examples and troubleshooting documentation, are not as mature as those of traditional Android development. Lastly, although Compose has proved to be more performant, specifically in complicated dynamic interfaces, there are unique situations where XML may still display superiority, such as static layouts which do not require frequent updates. Though these considerations are certainly valid parameters to apply to your decision, the Play Store is full of success stories from countless teams who have taken these factors on to reap the rewards of all that Compose has to offer. To name a few, Dropbox reduced the time to rebuild its search feature by 40%. Clue recorded development speed increasing up to 3 times compared to their legacy codebase. The Google Drive team saw a 57% reduction in the lines of code required for their home screen, and instead of needing 9,000 lines to test around 62% of the UI, they only needed 2,000 to test over 80%. And as a final mention, the Lyft team reduced their code for UI components by 60% using Compose. When taking all of this into consideration, it's clear that the stability, growth, and advantage that Compose offers is well worth the investment. I hope with this update on the state of Compose, you'll strongly consider what it could do for you and your team, no matter what phase of development you are in. Thanks for taking the time.